Welcome, everyone. Today, we are focusing on a critical capability within the AI ecosystem, machine learning. We will demystify the end-to-end lifecycle of a machine learning solution so you can drive real business value. Let's get started. Welcome. Generative AI gets the headlines today for creating content, but machine learning is the critical engine driving enterprise prediction and automation. What exactly is it? It's a branch of AI where computers learn from data to improve over time without being explicitly programmed. Why do we use it? It excels at numerical prediction, classifying data, and clustering customers into market segments. How does it work? By finding hidden patterns in vast amounts of historical data. Our deep dive today focuses on the ML lifecycle, which isn't a one-and-done IT project, but rather a continuous, iterative loop of improvement that requires strong business leadership. Looking at this diagram, we contrast generative AI with machine learning within the broader AI ecosystem. While Gen AI branches up to create new content, machine learning branches down to focus on prediction and classification. Notice how the ML path leads directly into an iterative lifecycle node. This is a crucial concept. ML isn't traditional software that you deploy and forget. It learns, predicts, and then needs to learn again as new business data arrives. Understanding this cycle is your key to AI success. The machine learning lifecycle always starts with stage 1, defining the task. What does this mean? It means clearly identifying the specific business problem the model must solve. Why start here? Because building a model without a clear goal results in expensive science experiments with zero return on investment. How do we execute this? Business leaders and technical teams must collaborate closely to ensure the model supports a specific, high-value decision like predicting customer churn. For our deep dive, remember that you must define what success looks like, the exact KPIs and metrics before a single line of code is written or data is gathered. This flowchart shows the initial, critical decision gate. We start at the top with a business problem. The diamond asks, is ML the right tool? If it's a simple rules-based problem, we exit left to use standard IT logic. If yes, we must move down to define success KPIs. Only when those metrics are locked in do we align with the data team and proceed to the data phase. This ensures tight alignment between your technological investments and your core business goals. Stage 2 is where the heavy lifting happens, collecting and preparing data. What are we doing? We are gathering historical data from internal or external sources and structuring it. Why is this so critical? Because models learn exclusively from the patterns in the data you provide. If your data is biased, incomplete, or messy, your model's predictions will be too. How do we do this? Data engineering teams deduplicate and organize the information, while business leaders ensure the data is actually representative of the real-world problem. Our deep dive here emphasizes that breaking down departmental data silos to create a unified, high-quality data estate is your most important foundational step. This pipeline illustrates the data preparation journey. We start on the far left with disconnected raw data silos. The data is extracted, then runs through a rigorous clean and deduplicate node to remove errors. Next, it is formatted and enriched, making it mathematically understandable for the algorithm. Finally, it arrives at the destination, a unified database of high-quality training data. This clean dataset is the actual fuel your machine learning model needs to learn effectively. Welcome to stage 3, train and validate. What happens here? We feed our clean training data into an algorithm so it can learn. The basics involve the model iterating over millions of data points to discover hidden mathematical relationships. Why do we validate? We must ensure the model doesn't just memorize the historical data, but can actually accurately predict outcomes on brand new, future data. How is this done? Data scientists run multiple experiments, tuning parameters to find the best performing model. For our deep dive, we use a technique called holdout validation, testing the model on a dataset it has never seen before to definitively prove its real-world accuracy before deployment. Look at this training loop on your screen. Training data feeds directly into algorithm training. We evaluate the performance at the decision diamond. If the predictions are poor, we loop back up to tune parameters and train again. This is a highly iterative cycle of scientific experimentation. Once performance metrics look good, we move to the crucial step, validating on unseen data. If it passes this rigorous test, the model is officially ready for deployment. Stage 4 is deployment. What does deployment mean? It means taking our validated model out of the laboratory and integrating it into your live business applications. The basics involve connecting the model's predictive brain to the software your employees or customers actually use. Why is this exciting? Because this is the exact moment your investment transitions from an IT cost into a tool that generates real business value and ROI. How do we deploy? We use enterprise-grade platforms like Azure Machine Learning to host and package the model. Our deep dive focus is on creating secure APIs. This ensures that when your CRM or website requests a prediction, the data transfer is secure, fast, and highly reliable. This diagram shows the critical bridge between data science and business operations. The validated model is handed off to Azure ML hosting. It is then exposed as a secure API endpoint. Think of this endpoint as a secure gateway, allowing your existing business applications to request predictions in real time. Finally, this seamless integration empowers the end user, whether it's a sales rep or an automated system, to make a data-driven decision instantly. Stage 5 is arguably the most important for long-term success: monitor and manage, commonly known as MLOps. What is it? It's the continuous oversight of your model in the real world. The basics include tracking its accuracy, logging lineage data, and monitoring system health. Why is this mandatory? Because market conditions and customer behaviors constantly change. If you leave a model alone, its accuracy will inevitably degrade, a concept called data drift. How do we manage this? We use MLOps tools to set automated alerts that notify us when the live data stops looking like our training data. For a deep dive, remember this: the ML lifecycle is a circle. When we detect drift, MLOps triggers a new cycle to collect fresh data and retrain the model. This cyclical diagram represents the heart of MLOps. We monitor the live production model's predictions constantly. We hit a decision gate. Is data drift detected? If no, operations continue smoothly. But if customer behavior changes and drift is detected, we follow the yes path. We alert the data team, initiate a model retraining phase with fresh data, and seamlessly deploy the updated model back into the live environment. It is a continuous, automated cycle of improvement. As business leaders, you face a strategic choice for every AI initiative: build versus buy. What does this mean? You must decide whether to use Microsoft's pre-built Azure AI services or invest in building a custom ML model from scratch. The basics are simple. For standard tasks like language translation or vision, pre-built models are incredibly fast and ready to use. Why do we care? Because executing the full ML lifecycle for a custom model requires highly specialized talent and significant cloud compute budgets. How do you decide? You evaluate your data. If your process relies on highly unique, proprietary data or strict compliance rules, you must build custom. Our deep dive recommendation: always start by asking if an off-the-shelf solution can solve the problem before committing to a custom build. Let's navigate this strategic decision tree. For a new ML use case, we ask, is the task standard? If yes, we follow the path to buy pre-built Azure AI, yielding fast ROI and lower costs. If the task is not standard, we ask, does it involve unique intellectual property or strict compliance? If yes, we build a custom ML model. This path requires managing the full iterative ML lifecycle we just discussed, resulting in high precision, but at a higher operational cost. Let's tie the entire lifecycle together with a real-world, high-stakes use case: financial fraud detection. In stages 1 and 2, a bank defined their exact risk reduction KPIs and aggregated millions of historical transaction records. In stages 3 and 4, data scientists trained a custom classification model to recognize fraudulent patterns, and IT deployed it securely into the live payment gateway. Now, as transactions occur, the model scores them in milliseconds. Crucially, in stage 5, MLOps tracks performance. When scammers invent new tactics, the system detects the data drift and triggers a retraining cycle. The business value: the bank reduced fraud losses by 30% while drastically minimizing false alarms for legitimate customers. This proves the massive ROI of a well-managed ML lifecycle. This final diagram shows the ML lifecycle actively protecting the business. Clean transaction data trains the fraud model, which is deployed to the payment gateway. When a live transaction hits the gateway, the model instantly classifies it, routing fraudulent attempts to block payment and safe ones to approve payment. Notice the continuous feedback loop. The gateway feeds data into the MLOps drift monitor, which loops back to training, ensuring the model stays vigilant against new threats. This is the true power of machine learning.